Hello everyone, I'm Paul and today we're solving problem 3337, total characters in string after transformations 2. This is the second part of a problem we solved recently and this is definitely a hard problem. I don't think you're seeing this in any job interview and actually I don't think you can solve this if you don't know the trick. So here we'll go through the intuition, the approach and the efficient solution step by step. We're given a string s, an integer t, and an array nums. S is a string we need to transform, t is the number of times we need to transform the string, and nums is how we need to transform the string. Let's see what this means with an example. Let's say this is a string, let's say t is 1, and nums is an array of size 26 where each index represents one letter in the alphabet. So for example, index 0 is A, index 1 is B, index 2 is C, and so on. And each value is the next characters we need to transform the current character with. So in this example, t equals 1, so we need to do only one transformation. And in this case, the first character is an A, and we need to transform the A with the next two characters in the alphabet. So A is now BC, the next one is B, and B is here at index 1, and nums at 1 is 2, so we need to transform B with the next two characters, so B is C and D. Similarly, in C, nums at C has a count of 2, so the next two characters from C are D and E, and finally nums at D is also a 2, so we'll replace D with E and F. So after one transformation we have 1, 2, 3, 4, 5, 6, 7, 8 characters, so we return 8. Now the first observation we can make here is that T is too big, it's 10 to the power of 9. This means we can't do normal simulations here. We need to think about something faster. And the key word here is matrix exponentiation. So now let's see how this works and how can we solve this with an example. Now let's say we have this matrix, and for simplicity we are using an alphabet with only 4 characters, A, B, C, and D. First, we want to fill this matrix with the values from the array nums. So for example, nums at index 0, meaning when the character is an A, in this case we want to replace the A with the next two characters. So the A will transform into B and C. And we will use a 1 for every next transformation and a 0 for every not transformation. Similarly, we know that nums at 1, meaning nums at B, is 2. This means that B will transform into C and D. This is 0, 0. C is also a 2, so this will transform into D and A. And this is 0 and 0. And D is also a 2. So this will transform into A and B, and this is 0 and 0. So remember T is 1 and this is the string. So this is the final matrix, and let's see how can we use this. First we will get the frequency of each of the characters in the string. The frequency for A is 1 and so on. And next we want to multiply each of these frequencies for each value in each row, and then we want to add everything and return the result. First let's put the frequencies here. The frequency is 1 for all characters, and now we are doing 0 times 1 is 0, plus 0 times 1 is 0, plus 1 times 1 is 1, plus 1 times 1 is 1. And this is 2. Similarly, 1 times 1 is 1, plus 0 times 1 is 0, plus 0 times 1 is 0, plus 1 times 1 is 1. This is also 2. Next, 1 times 1 is 1. 1 times 1 is 1. 0 times 1 is 0, and 0 times 1 is 0. This is 2. And next, 0 times 1 is 0. 1 times 1 is 1. 1 times 1 is 1. And 0 times 1 is 0. So this is also 2. So the result for this is 8. It's 2 plus 2 plus 2 plus 2. Let's see what this means. This means that this string after t equals 1 will transform into BC, CD, DA, AB. And this has 1, 2, 3, 4, 5, 6, 7, 8 characters. That's why the result is 8. And actually you can see these values in this matrix. For example, BC is here, CD is here, DA is here, and AB is here. Now we know this is the result when t equals 1, but what happens if t equals 2 or t equals 8? What can we do there? Well, the key here is that we can get every new state of the matrix by multiplying the matrix by itself. And if we want to find the final state of a matrix, we need to multiply the matrix by itself t many times. What this means is to get any final state, we can do matrix to the power of t. And this is basically a solution, and this is what's called matrix exponentiation. So now we will see how can we multiply matrices. So we want to know how can we multiply this times this, and this will be equal to some matrix. Okay? Now the way to do this is to take every value in every column and every row in both matrices, multiply them and add them. Let's see how. First we take 0 times 0, which is 0, plus 0 times 1, which is 0 also, plus 1 times 1, which is 1, plus 1 times 0, which is 0. This is 1, so we put a 1 in the first position. Next we are here, so we are multiplying this row with this column, and 0 times 0 is 0, plus 0 times 0, which is also 0, plus 1 times 1, which is 1, plus 1 times 1, which is also 1. This is 2, so we put a 2 here. Next we are here, so we are multiplying this row with this column, and 0 times 1 is 0, plus 0 times 0 is 0, plus 1 times 0 is 0, plus 1 times 1 is 1. So this is 1, so here we put a 1. Now we are here, we are multiplying this row with this column, so 0 times 1 is 0, plus 0 times 1 is 0, plus 1 times 0 is 0, plus 1 times 0 is 0. So we put a 0 here. And now I think you get the idea. We need to repeat this process and fill this new matrix. So basically this is the matrix when t equals 2. This is when t equals 1, and this is when t equals 2. So from this we can get the final result as before. we can build a frequency array with these characters, which will be this one, and we can use these frequencies here. So these are the frequencies, and now we want to multiply the value in each row for each frequency and sum everything. So 1 times 1 is 1, plus 2 times 1 is 2, plus 1 times 1 is 1, plus 0 times 1 is 0. This is 4. Next, 0 times 1 is 0, plus 1 times 1 is 1, plus 2 times 1 is 2, plus 1 times 1 is 1. This is 4 also. Now 1 times 1 is 1, plus 0 times 1 is 0, plus 1 times 1 is 1, plus 2 times 1 is 2. This is also 4. And finally 2 times 1 is 2, plus 1 times 1 is 1, plus 1 times 0 is 0, plus 1 times 1 is 1. And this is also 4. So the result for this is 4 plus 4 plus 4 plus 4, 16. So this is the result, and this is the value we return. Now let's see what this means. In the first transformation we got the following, and in the second transformation we got the following. And here we have 16 characters. And for example, at first A became B and C, and B and C then became C, D, D, A. And you can see this here. We have 2 D's, we have 1 C, and we have 1 A. Because remember, this is the matrix for the second transformation. So this is it for the approach, and now we will go with the code, and hopefully you will get the idea. First we'll go here and we'll say mod equals 10 to the power of 9 plus 7. And next we want to create 2 functions. One multiply, this will take 2 matrices A and B, and one we'll call this power matrix. This will take a base matrix and an exponent. And next we will fill this. So first here we will create a new matrix. This is an array which has an array inside times 26 for every value in range 26. And next for I in range 26, for j in range 26, and for k in range 26. This is how we can iterate and multiply matrices. Here we'll say new matrix at ij equals new matrix at ij plus a ik times b k j, and we need to mod this by the required value. And finally here we return a new matrix. Next, here we want to fill this function. We'll create a new matrix, new matrix. This equals an array 0 times 26 for every value in the range 26. And this is what's called the identity matrix. We need to fill the diagonal of this matrix because this will be the base for every initial calculation we are doing here. So for I in range 26, new matrix I equals 1. This is very important because otherwise the whole matrix will be a 0, and that's not what we want. The first time we are multiplying this identity matrix with another matrix, we are getting that other matrix, and that's what we want. And next, while the exponent is bigger than 0, if the exponent multiplied by 2 is 1, new matrix equals our function multiply the new matrix times base. Here we are multiplying the matrix we just created with the base we have here in this function. That's why we need to fill this diagonal with ones, otherwise this won't work. Next, base equals multiply base times base, and once we have this, we say exponent divided equal 2. Okay, so this will go on and on until we have no exponent, and finally we return the new matrix. And now we can start with the main function. We'll create a new matrix. This is a nested array. The 0 is times 26 for every value in the range 26, and for I in range 26, for j in range. Here we need to fill this matrix with the final state after the current transformation. So we will take every value from 1 up to nums I plus 1, because nums I is included, and here we will put into matrix I plus j modded by 26 I a 1. Okay, this is the same we did a few minutes ago, but here you're seeing it in code. And now we can get our final matrix after all transformations, and we can do this with the function we have, pow matrix. This will take matrix as an argument and the transformations. Next, we want to build our frequency array. Map equals 0 times 26, and for every value in the string, map at or x minus or a plus equal 1. This is how we create the frequency array. And now result is initially a 0, an array with 0 times 26, and for I in range 26, and for j in range 26, we are iterating every value in the final matrix. Result at the I row equals result at the I row plus final matrix I j times map at j modded by the required value. And finally we return the sum of the result modded by mod. Now this is the entire code. About time complexity, this function runs in constant time. This runs in log t time. This is constant. Nums, every value nums can be up to 25, I think. So we can say this runs in constant time. This is log t. This is n time. So the overall time complexity, I think it's big O of n times log t. And space complexity is big O of 1 because we are building matrices everywhere with constant space. If you think I'm wrong, please correct me in the comments. I love to learn about this. And that's it. As you can see, this is a very hard problem, especially if you don't know the trick. And now we'll submit this and see if it works. And as you can see, this works. So if you didn't get the full idea, I recommend you to go through this video again, and maybe you will get some important information that can be useful for future problems. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.